I'm Kris Burkewitz, assistant professor in cell and developmental biology here at Vanderbilt. So we're interested broadly in the biology of aging, and we tend to break that into three bigger, broader types of questions. The first being, what are the cell and molecular level changes that are occurring as we transition from youth into older age? The second, and a little more difficult, is to identify which of those molecular changes are actually linked or causing the sort of negative consequences that we think of as we think of aging, things like chronic disease risk, neurodegeneration, diabetes, and just the morbidity and frailty that accompanies old age. And the third and most difficult question, I think, is to ask whether there are ways in which we can intervene in that process to prevent or delay those changes from occurring in such a way that we can reduce or prevent the risk of chronic disease in older age. So basic science is really everything in the aging field. I think for most of human history, aging and aging science and the attempt to extend lifespan has been the realm of snake oil salesmen to some extent and pseudoscience. And so it was really basic science efforts that began, I would say, in the last century, but that have really accelerated over the past 20 years and grown dramatically, that have really set the foundation to take aging biology from pseudoscience into setting a real foundation that we can build sort of a translational outcome on top of. And it's a really exciting time for that, I think, because the basic science is just now, for the first time, really beginning to show up in the clinic. The first clinical trial for modifying age-related damage and outcomes and diseases is ongoing right now. We don't have the results yet, but we are still in that stage where we're setting the basic science foundation for this field, and I think there's a lot more to do there before we'll really fully implement what we're discovering in the clinic. So I think that my advice for students that want to join the aging field, there's two parts of it. Part can be generalized to anyone that wants to do biomedical science, and that is to make sure that you have identified a problem, a question that you are interested in and passionate about, that is deep and complex, so that the mounds of negative results that we all experience in science won't ever dissuade you from continuing in that path. More specifically in aging research, I think I would suggest that students really try to find an environment, by which I mean a mentor and an experimental system that allows you to be really creative, that allows you to take risks with your research and to ask questions that are innovative and new. I think the aging field really benefits from that type of perspective and that type of research. And so that's really all about choosing the right place to do the work that you want to do.